Good morning, students. Already a previous class we will discuss about the different bar in load. The same method one formula we'll seeing now. A steel of rod 3 centimeter diameter is enclosed controlled in a hollow rub copper tube of external diameter 5 centimeter and internal diameter of 4 centimeter. Okay, we will note it down the point in enclosed centrally in a hollow copper. This is a hollow copper tube. Okay, then the composite bar is the subjected to an axial pull of 45,000 Newton. Okay, full stop. If the length of each bar is equal to 15 centimeter, determine the stress in the rod and tube. Okay, so we will determine what will find the problem or determine the problem. Okay, the stress in the rod and tube, load carried by each bar. Okay, the two of determine the problem we will find out. Okay, take E for a steel is equal to 2.1 into 10 to the power of 3 Newton per mm square. So already you will know about E means what? Young's modulus will given in the problem, and for copper is equal to 1 point into 10 to the power of 5 Newton per mm square. Okay, so here you will see that E1 E2. So one thing is steel, another one is copper. So steel is equal to 2.1 into 10 to the power of 5. The copper will 1.1 into 10 to the power of 5 Newton per mm square. Solution given. So first of all we will discuss about the show in the diagram. Okay, the total length of the diagram of a steel and copper tube 15 centimeter. Okay, steel rod will enclosed the hollow copper tube and steel. Okay, the length is 3 centimeter. Another one is 4 centimeter is hollow to hollow. Outer diameter is 5 centimeter. Okay, copper tube and steel rod. The given the problem, diameter of steel rod is equal to 3 centimeter. Area of steel rod AS is equal to, AS means what? Area of steel, pi divided by 4. The diameter will given in the problem 3 centimeter into 10, so 30 square. 706.86 millimeter square. External diameter of copper tube 5 centimeter is equal to 50 mm. Internal diameter copper tube 4 centimeter is equal to 40 centimeter mm. Area of copper tube is C is equal to pi divided by 450 square minus 40 square mm square is equal to 706.86 mm square. Okay, same thing is of area in copper tube and steel also. Axial pull on composite bar P is equal to 45,000 Newton. Length of the each bar L is equal to 15 centimeter. Young's modulus of steel ES equal to 2.1 into 10 to the power of 5 Newton per mm square. Okay, copper. Young's modulus copper CEC is equal to 1.1 into 10 to the power of 5 Newton mm square. The stress in the rod and tube rho S equal to strain in steel, PS equal to carrying load steel of rod. Okay, and then same using the copper also, rho C PC. Now strain in steel, strainer in copper. the formula will knowing steel. So rho s equal to es divided by ec into rho c is equal to 2.1 into 10 to the power of 5 divided by 1.5 into 10 to the power of 3. We will got it 1.909 rho c. Okay. Now stress equal to load divided by area. Load is equal to stress into area. Load on steel plus load on copper is equal to total load. So we will know in load of steel, load of copper. So load of steel formula for rho s into as plus rho e into ae is equal to p. So 1.909 rho c into 706.86 plus same 706.86 is equal to total load will 45,000. Okay, rho c will common. So we'll cut it at 2056.25 rows is equal to 45,000. Row 2 here about converted into the multiplication is divided 2056.25. The calculator will using the scientific calculator 21.88 Newton per mm square. Okay. Now applying to the rho C into rho S. Already we will know about the rho S is equal to 1.909 into rho C will 2.188 Newton per mm square is equal to 41.77 Newton per mm square. So load carried by another one is determine or find out load carried by each bar. Load is equal to stress into area. Load carried by steel rod PS equal to rho S into AS. 41.77 into 706.86. Okay, totally 29,525.5 Newton. Okay, the copper tube PS equal to 45,000 minus 29,525.5 minus is equal to 50,474.5 Newton. Okay, clear about this one. Thank you.